Okay, so welcome everybody. So as Mark said, I have to say a few words about one of the sponsors, which is Planet S. So Mark did this very well. It's not planets, but it's Planet S. Planet S is a National Center for Competence in Research. So it's a national program that has been founded by the Swiss National Science Foundation. And we have a privilege to have here the co-director. Where is Stefan? He's there. The director is Willy Benz from Uni Bern, and the co-director Stefan Udry from Uni Geneva. So this is a national program led by these two universities, Bern and Geneva, with members from ETH in Zurich, Uni Zurich, and EPFL in Lausanne. We have also some other partners which are not academic, like Muséum d'Histoire Naturelle and Musée d'Histoire des Sciences in Geneva, the City of Zermatt, the Museum of Transport in Lucerne, and Ionite, which is a spin-off in Bern, and the Swiss Space Center. Just to give a few numbers. So this is the budget that has been allocated by the Swiss National Foundation. So it's 18 million francs for 4 years, and we have on top of that 8 million from the two leading houses. So it's quite a big program. We started in last June, so that's a very recent initiative, and we have been founded for 4 years with two possible additional extension of 4 years. So the program could last up to 12 years, and we hope that it will last up to 12 years. If you want to have more detail, you can look at this website that we launched at the end of January. So there are many people, in fact, in the room who come from the NCCR, so you can just sleep for a few minutes because all what I will show you already know. So the philosophy of the NCCR is that we are building on the already existing strength of Switzerland in the domain of exoplanets. And so this is a slide that Willy Benz has done. So it's a very fancy slide. You will see everything moves. So that's the slide that we show all the time. So we start with some existing strengths. So in theory, instrumentation and laboratory analysis. And then we want, so you see it start to be a puzzle. We add some new project that you see everything fits together very nicely, and you start to see an image behind, which is kind of the goal of the NCCR, one of the goals of the NCCR. And so this is the puzzle. Now, you know, if you take a puzzle just like this, it's just not extremely strong. So you have to have some structuring effect. These are these big piece that you put on the side. So these are platforms, so some part of the NCCR which provide the structure of the NCCR. And at the end, all of this project is developed in the framework of the international framework. So like we work with ESA, ISO, with some partners from academy, industry, and also schools and museums. So just to present a little bit the science, we have, so Planet S is, the goal is to study planets inside and outside the solar system, and we have three keywords in our science. The first is the origin of planets, with two parts. This first one, which I think is very related to what we will do this week, protoplanetary disks, so they provide kind of the initial condition. So we study the physical and chemical properties of disk with models and resolved images. And so this is for extrasolar planets. And in the case of solar system, we try to put constraint on the protosolar nebula using some meteoritic data that we collect. The second part on the origin is the formation of planetary system itself. So for exoplanets and, looking at, in general, planetary system formation, we have, so our goal is to study what are the physical and chemical processes that are important during the formation of planets, and to look at the interaction and dynamics between forming planets. In the case of the solar system, we have different science goals, looking at COMETs as proxies of planetesimals, and trying to put constraint on the accretion and loss of volatiles by planetesimals and forming planets. In fact, Mark, this is a very terrible thing. I wish you good luck, dear speaker, because this is terrible stuff. You'll see. So the second part is the evolution of planetary systems. So evolution of the interior. So we are developing some internal structure model of planets this is a kind of a nice image, to understand, in particular, the mass-reduced relation of planets. We are working on the atmosphere of planets from giant to terrestrial planets. So for the moment, we focus more on giant planets, and we will go toward lower mass planets as time goes on. This is done using models. In particular, Kevin here can explain more about these models. Measurement in spectra and in situ measurement. And one of the goals is to go toward the habitability of planets. So this is concerning only low mass planets. And finally, we also deal with dynamical evolution, so how the architecture of planetary systems evolve with time. And Stefan can speak more about this. The third part is characterization of planets. So this is done with laboratory analysis, in particular for solar system planet, but also for exoplanet using, so measuring physical properties of ices. And this is also done in the framework of the Data Analysis Center for Exoplanets. So again, I think Stefan can explain all what you want about DACE. I will come back later to this center. We have some activities for ground-based observation, scientific exploitation of different data, so direct imaging with SPHERE, transit with the next generation transit search, and high precision spectrography with HARPS, HARPS-North, and Espresso. We also are very active in the development of new instruments at the ESO, on NTT, VLT, and on the EELT. So we have participated, and we have had, I think, a very strong participation to the NIRPS proposal on the NTT. We are working on the ERIS project for VLT, so I don't know if Michael is around. I don't know, but he can explain to you everything about ERIS. And finally, on the, for the longer-term future, we work on the preparation of some instruments for the EELT, like METIS, IRIS, and PCS. So this is for the ground, and now for space, we look. So we have activities on the scientific exploitation of some space missions for the solar system and for extrasolar planets. And we also are very active in the development of future mission, in particular of the ESA Swiss-led satellite CHEOPS. So this is the structure of the NCCR. So as you see, it's quite complicated. There are many people involved there. So we have different parts in the NCCR. In gray, you have the leading and coordination. So the NCCR is led by Willy Benz and Stéphane Udry. And these two directors are assisted by the executive board. So there is Michael is one of the members of the board, and there are 7 members, like the 7 dwarfs, maybe, I don't know. So they decide on the scientific development of the NCCR, and then their decisions are put into action by the NCCR program office that I'm leading. Then we have the administration, the platforms, and the project. So as you remember, this provides the structure of the NCCR, and this provides the research itself. So I will not enter in all the boxes there, just to mention here we have Kevin, who is in this box here. So now these are the 7 research projects. So of course I will not read all of this. Just to mention only the title, the first one, led by Michael Meyer at ETH, deals with circumstellar disk and planetary systems, in particular young planetary systems. The second one, led by Maria Aschenbechler in ETH Zurich, on the origin and evolution of volatiles in planets, so using meteoritic measurements. Project 3, Atmosphere of Exoplanets, led by Francesco Pepe in Geneva. Project 4, Solar System Data Analysis, Laboratory Investigation and Modeling, led by Nick Thomas in Bern. So there are members of the project that are in the back here. Project 5, where I and Kevin are involved on planet formation and evolution, so a theoretical project led by Willy Benz in Bern. Number 6 is led by Ben Moore in Uni Zurich, so numerical laboratory for planet formation. So they are doing high-resolution simulation, in particular of disks. So, and we have one member of this project 6 in the back. And project 7, led by Stefan, with a very long title, Multifaceted Determination of Planet Properties and System Architecture. Very nice one. Okay, so this is an overview of the project. The color code here is related to the different institutions, and the idea of the NCCR is to provide synergies between these different universities. So, and you see that at every project you have contribution from a lot of different places in Switzerland. And some free projects are multi-site, meaning that the activities are really shared between different places. And we have a number of PhDs that are shared between different projects. And I think there are, no, two of them are in the room. Should be in the room. Now, to speak a little about the platforms, we have these 5 platforms to provide the structure of the NCCR. The DACE platform, which goal is to provide some tools to exchange and to analyze data on exoplanets, data from different sources. The second one related to exploiting the science of chaos. So these are 2 science platforms and 3 more managerial platforms, in particular the academic platform, which is very important for us today because, oh, Michael, hi. So led by Michael. So the academic platform has different action, in particular supporting some summer winter schools. So the Saas-Fee school is supported by the academic platform, so you can thank Michael in the back. The second platform is technology, so enabling technology transfer between the NCCR and the industries. And the last one is outreach, so we have a lot of outreach actions. So again, all of this is on the NCCR website, so you can find details of everything. So the idea of this platform is that it provides the structure of the NCCR, and so to make a coherent program out of the different projects. So just to finish, the idea on the long term of the NCCR with the projects and the platform is, if it's successful, to lay the foundation of a Swiss Institute for Planetary Sciences that should be the future of the NCCR in more than 12 years. So I think I've said enough, and now I think we can go to the presentation. If you have questions, again, I can just show you the website. So if you want to have more detail, just look at this website. Thank you.